Alright, so I've already started writing this up a little bit. So with this one, it tells you the function here, right? F equals ax squared, right? And you see it's, right, so f versus x would be a top opening parabola, right? So if you want to make that line, that relationship linear, if you square all the x values and replot it, you'd get a straight line, right? So this one would be like f equals, some constant ax squared. This one is f equals same constant ax squared. Y equals mx plus b. We can get a from this. We can't get a from f versus x graph, right? We can't do it. So what we do here, this is something we do in physics all the time because linearization. If we square all the x values and replot the data, right, we'll get a straight line. And then we can use y equals mx plus b, right, to figure out the equation. So y is your force, m is this constant they're calling a, x variable here is actually x squared. It's kind of unfortunate they're using x here, but remember that's like a compression distance. So f equals ax squared, and y-intercept here is going to be 0. So I literally calculated this by squaring all these. You have to make sure you square the units as well. Then we are asked to plot it. Okay? You have to put labels on your axes. This is going to be x squared we're going to put on this axis down here. Now this has got to get out to 0.0625. So let's see. We go 2, 4, 6. No, 2, 4, 6. Okay. So 1, 2, 3, 4, 5, 6. Point 0.01, 0.02, 0.03, 0.04, 0.05, 0.06. Alright, I gotta get up to 100 on the x-axis. So 1, 2, 3, 4, 5. Okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Alright, and you don't need to put units next to each number if you've put in units on your labels. So now we're actually going to plot this data here. So f versus x squared here. Now, I guess, yeah, you want to put f on the y-axis. Alright? Alright, so anyhow, even though it looks like that, no, I guess that was probably the thing they measured. Is measured. Okay, so that was the thing we measured, so that should go on the y-axis. Alright, so at 0.0025 we stretch it to. So that's going to be like here, it's going to be 4 newtons. 0.1 is going to be 0.17 newtons. That's going to be like up here. 0.225, which is like here, is going to be 38, which is like here. 0.04 is 68, which is like here. 0.0625, which is about here, is like 106, so it's right there. Now, you do want to use a straight edge here. You will have a ruler on the AP exam. Put a fit line on here. Alright. Don't connect the points, use a fit line. Now, here's an argument we had in class. Using your graph, calculate A. Alright. A is the slope of the line. A is the slope of the line. Alright? Some people are saying, oh, okay, I'm gonna plug in, I'll do the work up here. I'm gonna plug in one of these points to the function. I'm gonna plug in one of these points, 4 and 0.0025 to the function. I'm gonna calculate A. They might give you a point for that, but you're not gonna get full credit. That is for sure. It says using your graph, so that means calculate the slope. So rise over run. So A equals rise over run. All right, and what you want to do is you want to pick 2 points on your graph that are, you know, pretty much on the line, maybe from there. And you want to get them as wide as possible, you know. Oh, I don't know. Maybe there and there, okay? So rise over run. So the rise here is 10, 20. And just be careful drawing on your graph, all right? Just use dashes so you don't mess it up if you're going to draw right on it. So the rise here is 10, 20, 30, 40, 50. 50 newtons in 1, 2, 3, 4, 5, 6. 1, 0.1, 0.2, 0.3. You got to be careful though. 0.03 meters squared. So A is 50 divided by 0.03, which is about 1,700 newtons per meter squared. Make sure you put the right units on there. Next part says calculate the work done by compressing the spring 0.1 meters from its equilibrium length. So that's beyond our graph here. So we got to assume this continues on. It's not the area under this curve though, okay? It would be the area under the original curve, F versus X, which is, you know, so really what we're going to do here is the work done is the integral of force with respect to position. All right? So for this graph, it's the work done is integral from 0 to 0.1 meters of 1,700 x squared dx. So you have to put in the number that you found for the slope, whatever that might be, for A. All right? So that gives 1,700 x cubed over 3, evaluated from 0 to 0.1. All right? So that's going to equal 1,700 times 0.01, or 0.1 to the 3. Divide that by 3, I get about 0.57 joules. All right, that's how much energy was stored in the spring when the cart hit it and compressed it. So, the KE before equals the energy stored. All right, so the cart hits it with 1/2 mv squared, and that stores up 0.57 joules of energy. So that means that's what our initial kinetic energy must have been. So now I go over here, 1/2 of 0. What was the mass of this? 550 kilograms times v squared equals 0.57. Right, so v squared equals 2 times 0.57 divided by 0.50. You don't need to show units throughout the whole calculation. They don't care about that on AP exam. As long as you put them in there once, you're good to go. So second square root of 2 times 0.57 divided by 0.50 gives us about 1.5 to 2 sig figs, 1.5 meters per second. Must have been the speed of the cart when it hit that spring. All right. Next one here, U of X. Okay, 0.5 kilograms experiences a force that is associated with a potential energy function. U of X equals that, where U is in joules and X is in meters. Sketch U of X versus X. All right, so it's 0. All right, so we're just going to evaluate it. So at 0, it's 4 over 2, which is 2. All right, at 1, it's 4 over 3, which is 1.3. 3. So out there. This 2, it would be 1. 4 divided by 5 is 0.8. 4 over 5 is 0.8, so that's right about here. 4 over 6 is 0.7. So it's going down. 4 over 7 is 0.6 roughly. So there. Alright, and then, just try to draw your best curved line there. Okay. Determine the force associated with the potential energy given above. Okay, so you got to take the derivative of this. So it's the negative derivative with respect to x of 4 over 2 plus x. How do you take the derivative of that? So it's something called the quotient rule. Using the quotient rule, Mart. Yeah. All right. So, quotient rule. You remember it. All right. So, derivative of the top times the bottom minus the derivative of the bottom times the top over what? The bottom squared?